All right, you guys, hopefully you are ready for lesson 2.5. We're going to learn uh, product rule, quotient rule, and some trig rules. Okay, so far, don't worry about writing this. Show you guys something real quick. If I have a function plus another function, and I'm taking the derivative, I take the derivative of that one and the derivative of that one. And everything is great, and there is happiness in the land, okay? Unfortunately, it is not true if I have a function times a function. It's just not true. It doesn't work that way. I can't take the derivative of this one times the derivative of this one and get a proper answer. It just doesn't work. All right. So we have to use something called the product rule. Okay, so the first thing is you use the product rule whenever you are trying to take the derivative of two completely separate things, functions that are multiplied by each other. Okay, here is an example. This is a product function. All right. Okay, look at the pattern here. It says take f, so this is f, right? Take f and multiply it by the derivative of g. And then it's like, okay, take g, sorry, take g and multiply that right here by the derivative of f. Okay. Um, okay. Some people use u and v, and they'll go like, all right, they'll go like this: u, v, u prime, v prime, and they'll say, okay, I've got to multiply u and v prime, and I've got to multiply u prime and v. Okay. Now it doesn't really matter which order you go in because look, it's a plus right there. So even if I switch them around, it's going to be the same thing. Now, guys, this can be a little bit confusing. So one thing that like I usually do is I call it first, second. And first times derivative of the second plus second times derivative of the first. It's really easy. The more you say it over and over again in your head, the easier it will get, right? So I actually, the way I say it a little different than that. I say derivative of the first. Let's see here. Derivative of the first times the second plus the first times derivative of the second. However you say it the same time in your head over and over and over again until you get that right, okay? So let me show you how a product will work. Now, could I FOIL this out and do it that way? Yeah, sure, okay? But I want to do this using the product rule. So here's how we do it, okay? I usually start with derivative of the first times the second. So that's going to stay the same. Derivative of 3x squared minus 2 is 6x. All right, that's the first part. And then I leave the first the same and I do derivative of the second. And the derivative of 2x plus 3 is 2. And that is my product rule. Okay. Could we simplify this and combine like terms? Sure, but we could take if we had to, right? We could take the 6x and make that 12x squared plus 18x. And the 2, I could make that 6x squared minus 4 and turn this into like 18x squared plus 18x minus 4 or whatever. But that's not the important part. The important part is understanding how the product rule works, okay? Now, again, any order you do it in is kind of fine as long as you match up the derivative of one with that being the same, and then the derivative of that with that being the same. You just got to match them up, okay? Product rule is easy. Nobody ever really has a rough time on product rule. Now, let's move over to quotient rule, which looks so nuts, all right? Quotient rule is something divided by something, right? This is how I say it. Derivative of the top times the bottom minus top times derivative of the bottom over the bottom squared. Okay? It's kind of weird. I could definitely show you where it comes from, and I will at some point, but for the sake of this video, we're just going to use that. Now, that's why over here, it's talking about like top, bottom. Okay? I always say it the same way, and as long as you remember to start with derivative of the top, the rest of it goes along. So go derivative of the top times the bottom. It's a minus instead of a plus. Top times derivative of the bottom, and then we put it over the bottom squared. All right? Listen, if you want to see something funny, you can Google, I won't show you the whole thing, but quotient rule, quotient rule song. Let me put it in here for you. It's like, let's see, low, high, like low D high, high D low. I think it's like this guy. Okay, Google quotient rule song.
All right, we're gonna do the loady high. Loady high. Loady, loady.
Let's start over here.
Loady, loady, loady high. Loady, loady, loady high. Minus high-y, high-y, low. Minus high-y, high-y, low. All over low square. All over low square.
Somebody did this, right? So it's like low, like bottom times high, D high, low, D high, minus high, D low, all over low squared. I think it's freaking weird. If you love that, use that. Okay? Okay, so check it out. We have two functions here. I've got a top and a bottom. Okay, I start with derivative of the top. So I'm taking the derivative of this. That's going to be 4x minus 4. Okay, derivative of the top times the bottom. I leave the bottom exactly the way it is. And then I put a minus. And then, okay, I leave the top exactly the way it is. And I do times derivative of the bottom. The derivative of the bottom is negative 3. And then it's all over the bottom squared. Does that look like something I want to simplify? Absolutely not. But it just shows, I mean, you could, I guess, spoil all that out. It's kind of garbage. But it just shows you how the quotient rule comes about. Okay, so let's look at a couple other examples of product rule and quotient rule. All right, so here we go. Here's number 3. Is that a product rule or is that a quotient rule? This is definitely a quotient rule, right? Now this is a little bit tricky because I got to go derivative of the top. You really got to think on this one, guys. The derivative of the top, the derivative of negative 9 is 0 times the bottom, okay? And then I'll do the top times the derivative of the bottom, which is 10x, over the bottom squared. I am going to simplify this just because I want you guys to see something, okay? So look, when I simplify this, this becomes positive 90x over 5 squared is 25x squared. And if I reduce that by 5, how many times is 5 going to 90? 18 maybe? And 5 goes into 25 5 times, okay? And then one of those x's and one of those x's cancel and gives me x to the third. All right, now, when we were in class and I was doing these notes with you, I would say, big brain moment. I love it when I do big brain moment, right? The quotient rule is actually not the easiest way to do this problem, okay? This is my quotient rule way. Not actually the easiest way, you guys. And a lot of you may have seen this already, but we've done problems like this. And what did we do? Well, we just took the x squared and moved it up, right? But when we move it up, you can move it up here, I guess, it becomes a negative exponent, okay? It's actually x to the negative 2. And now, check this out. Derivative would be, bring that down, negative 9 times negative 2, 18 over 5 x to the negative 3. Or another way of writing that is 18 over 5x to the third. Okay? So let me tell you something. Quotient rule is not always the best way to deal with fractions, all right? If there is an x on the top and the bottom, quotient rule is the best. If there is only an x on the bottom, negative exponents is better, all right? We'll talk about that a little bit more in class. Okay, if Oh my goodness, this is giving me a bunch of information that is stressing me out, right? So I'm going to start with over here, okay? Now, guys, this is a product rule. Let's see if you can see why this is a product rule, okay? X squared is a function, f of x is a function. Do I know what that function is? No, I have no idea. It gave me some information about it, but I don't know what the function is, okay? It could be like a sine function, it could be x to the third, like I don't know. So when I go to get the derivative of this, I'm going to go, this is a product rule, right? Derivative of the first times the second. Okay? You guys with me on that one? Derivative of the first times the second. Then I'm going to go first derivative of the second. And we just call that f prime of x. Okay? Now that I have that, look, it says find g prime of 2. Okay, well that's going to be 2 times 2 times f of 2. And then 2 squared times f prime of 2. So like, what do I do with f of 2 and f prime of 2? How do I know what that is? Well, it gives it to me right in the problem, right? So 2 times 2, so that's 4, and f of 2 is 3. And then 2 squared, that's 4, and f prime of 2 is negative 4. That's 12. That's negative 16. So the derivative is negative 4. Okay? But I have to use a product rule for that because it was two separate functions. One was known, one was not known. All right? Okay, what rule is this? Pretty easy to see this one. Product rule. Now, when I have a constant in front, we could just leave it in front and do big parentheses, and we could just do e to the x sine x. But usually, because I don't want to, I call that my first product. Okay? So look, derivative of the first. 3 stays there. Derivative e to the x, e to the x. Times second. Look, it looks like I did nothing, but I did. I took the derivative of the first. And then I go first times derivative of the second. And the derivative of sine is cosine. Okay? Now, just to kind of show you something, this answer is perfectly fine. I'm going to leave it just like this. But sometimes on a multiple choice test, I want to show you guys this. Okay? It actually wouldn't leave your, wouldn't have that as an answer. It would have this as an answer. Okay, would you guys recognize that that's the same thing? Would you be able to say, oh yeah, that's, you know, um, just factoring out this 3e to the x from both terms? You'd recognize that, hopefully. So there you go. Okay. Okay, that's your product rule and your quotient rule. So we're going to practice those a lot in class. Now we're going to find the derivatives of all the trig functions, okay? All 6 trig functions. So we have, and they're down here, and they're kind of filled in though, so don't look. Don't look at that next page, guys. All right. We're going to find the derivative of sine. Well, we already did, right? That's cosine. We're going to find derivative of cosine. That's negative sine. We're going to find the derivative of tan. Uh, let's see. Secant. Well, I want to do it this way. Tangent, cotangent. Secant, cosecant. Okay, we're going to find all these. And you guys, you can find all of them just by knowing that the derivative of sine is cosine, the derivative of cosine is negative sine, and one trig identity. Now, I think we talked about this a few days ago, you guys, but this trig identity comes directly from the unit circle. Sine squared plus cosine squared is the hypotenuse squared, and the hypotenuse is 1. So this is a very important trig identity, and we're going to use that to find some other derivative, okay? Okay, so we want to find the derivative of tangents. Guess what I'm going to do? Instead, I'm going to find the derivative of sine over cosine. Because I don't know what tangent is, but I know what sine over cosine is. But guys, guess what rule I have to use? Guess what rule I have to use? Quotient rule. Okay? Now, if you want to see if you're super, super smart, you know who I'm talking to out there, right? Pause the video, see if you can figure it out yourself. Okay? See how fast you can do it. All right, I'm going to do a quotient rule. Ready? Derivative of the top times the bottom minus the top times the derivative of the bottom. Now, derivative of cosine is negative sine, all over the bottom squared. So, guys, when I multiply these together, I get cosine squared. When I multiply these together, a negative times negative, I get plus sine squared. And we have this trig identity up. And this trig identity says the sine squared plus cosine squared is actually just 1. So the derivative of tangent is 1 over cosine squared. It's a little hard to remember, though, because it's like 1 over. We don't really love that. So we write that as, you know that cosine, the reciprocal is secant. That's the derivative of tangent. That's what we're going to memorize, okay? So the derivative of tangent is secant squared. Going to memorize that one, okay? Derivative of tangent is secant squared. If you ever forgot, you could go back and derive it. But now that I've derived it once, never going to do that again. Never, never, never. All right? Here's our next one. Secant. Okay. So secant, we know, is 1 over. I could do a quotient rule here, too. All right? I can go like this. Derivative of the top. Now, guys, you got to be careful. That's a constant. The derivative of constant is 0 times the bottom minus the top times derivative of the bottom. And the derivative of cosine is negative sine all over the bottom squared. Okay, check this out. 0 times cosine is 0. Negative times negative is a positive. So I get a positive sine over cosine squared. Now that is my answer. That's just not how we say it. When we say the derivative of secant, we don't say sine over cosine squared. We don't say that, right? Here's what we do. Ooh, it's so tricky. Okay, we split this up into 2 separate fractions. We put a cosine there and a cosine there because we had squared. We split that up. Well, I'm going to put the sine there and I'm going to put a 1 there. Okay, big brain moment here, friends. What's another way of saying 1 over cosine? Secant, right? What's another way of saying sine over cosine? Tangent. That's the derivative of secant. So when I come over here, the derivative of secant is secant tangent. Okay? I derived the other two in very much a similar way. All right? For cotangent, I would change that to cosine over sine, derive it, simplify it. For cosecant, I'd change that to 1 over sine, derive it, simplify it. Okay? Here's what you end up getting when you do that. I don't want to take the time to do that. We might look at it in class, but here's what you end up getting. So we already did tangent. Your tangent is secant squared. Secant is secant tangent. Cosine is negative sine. Okay? Cotangent, it turns to negative cosecant squared, and cosecant is negative cosecant cotangent. It's real annoying with the signs. The biggest error people make is messing up those signs. Okay, you guys? Now, I have a great way for you to remember the signs. Kind of says it in here, but like these three all have negatives. These are all positive. So how can I remember which ones have negatives? Well, any derivative I take that starts with a co or a letter C, cosine, cotan, cosecant. Starts with a C, the derivative is negative. Okay? So it says, can you see a quick way to remember? If it starts with a C, the derivative is negative. But, I mean, also, look at the patterns, right? Sine, cosine, cosine, negative sine. Tangent, secant squared, secant tangent. Negative cosecant squared, right? Negative cosecant squared, negative cosecant squared. You're just going to have to memorize these. But they'll come pretty quickly, so you can write them down for now and then just memorize them as you can. All right, here we go. How do we find the derivative of 4 cotangent? Do I want to go back change that to cosine over sine and do a quotient rule? Heck no, we do not want to do that. We just go like this. Okay, there's a 4 in the front, that stays in the front. And what's the derivative of cotangent? Right here. Negative cosecant squared. Negative cosecant squared. That's it. I'm done. It's that fast if you have these all memorized. Okay? All right. Differentiate the following without using a calculator. Ooh, I love this. What rule do we have to use here? Product rule. You can tell it's a product rule if there's two separate x's. That means there's two separate functions, right? So here we go. I'm going to start with the derivative of the first, and the derivative of e to the x is e to the x, times the second. And then I'm going to do the first times derivative of the second. Now, what's the derivative of tangent? We can go back up here and look. The derivative of tangent is secant squared. That's my answer. That's it. Okay. Let's do this one. Another product rule. Okay, the derivative of the first, the derivative of secant, up here, you guys, right there. The derivative of secant is secant tangent, okay? The derivative of secant is secant tangent times the second, and then the first by itself, and derivative of the second. Remember, derivative ln of x is 1 over x? That's my answer. That's it. I'm done. Okay? So for my last question, let's go ahead and figure out how to apply this. All right. Without a calculator, find the slope of the graph at pi over 4. All right. What does slope of the graph mean? It means derivative. Okay. Actually, it's already written over here. I'm just going to use this. All right. The derivative. Well, the negative 3 would stay there. And then the derivative of tangent, if I look up here, is secant squared. And now I have to evaluate that at pi over 4. So I need to basically figure out what the secant squared of pi over 4 is. Okay, you guys got to start getting a little bit used to your best friend charts, right? Do I have it in here? No. Do I have it in here? Best friend chart. Okay. I'm trying to find secant squared pi over 4. Okay, secant is not on here, right? So I need to actually do cosine. Cosine of pi over 4 is root 2 over 2. Okay? Which means the secant of pi over 4, I flip that, is 2 over root 2. Which means the secant squared of pi over 4 is I square that. And 2 squared is 4, and the square root of 2 squared is 2. Need to go back and watch that again. Go back and watch that again. So secant squared is 2. Okay, I found cosine of pi over 4. I flipped it to get secant, and then I squared it to get secant squared. All right? So, go back to here. Yeah. So it's going to be negative 3, and we saw the secant squared of pi over 4 was 2. So that's going to be negative 6. All right? Okay, so really quickly, let's take a look at, we're going to do this in class tomorrow. I just want to kind of show you guys. Ooh, so fun. Couple things, okay? Check it out. Product rule, right? Product rule. Actually, this is having us do it two different ways. The first one, use the product rule and then do it without the product rule. We know how to do that because we have this shortcut of multiplying it out. Okay? Quotient rule, guys, this is what quotient rule looks like. Fractions like that. Okay? All right, and we're just going to look at different methods, and then tomorrow we're going to look at all these different types. It's going to be fun. Okay? But you guys got this. So hopefully you understand product rule, quotient rule, and all the trig ones. If you need more help on these, go back and try to derive cotangent, cosecant, see if you can get to that. But ultimately, all I care about is that you guys have those memorized, okay? All right. Hey, 24 minutes. Let's go.